And I don't know if we have time for questions or.
Thank you. Hey, thank you very much, Clay.
Sure,
I thought that was
sure.
a very exciting presentation. Mario's down there in the middle. Anybody like to shoot a question at Clay while we're here, hot on this topic? Or you're all stunned? Huh? Come on, yes. If you could state your name and company affiliation, we'd appreciate it.
I'm Stu Keller with ExxonMobil. Just on the human-robot collaboration, I recently saw a demonstration where a doctor performed heart surgery from the U.S. on a patient in the U.K.
Yeah.
Isn't that already sort of in progress as human-robot collaboration?
Well, interestingly, medical robotics are exempt from the existing safety standards. I mean, does this make sense, right? So, they have to go through rigorous clinical testing, right? Probably much greater than is involved with industrial systems. So they kind of have a separate path for ensuring safety. So there is, in fact, prostate surgery is widely done with robotic surgical systems today. The Da Vinci system is now heavily used for robotic surgery. And that's safe, it's effective. In fact, it's much better if any of you have to have this in your future, ask for the robotic solution. It is safe. In short, the industrial solutions are governed by different safety standards. So in some ways, the medical industry has gotten out ahead.
Tom, Corporation. The Connect technology, do you see that again as a new disruptive technology being used in the element of safety? Meaning being able to look at an environment, assisting people, being able to shut equipment down?
Yeah, absolutely. In fact, NIST has a working group currently, which is addressing that very problem. So one of the ways which you ensure safety in these sort of human-robot collaboration activities is by having a highly reliable and in many cases redundant sensing solution. And so what does that look like? Well, the regulations are evolving currently. And as I mentioned, NIST has the National Institute of Science and Standards and Technologies has a working group right now which is trying to address that, trying to provide guidelines on how do you ensure safety and reliability, especially for these human-robot collaboration situations. So it's already being done, not with the Connect, but with simpler sensors. So there are like laser scanning solutions from companies like SICK and others that are able to reliably detect the presence of humans in robotic workspaces. But right now, those are used mostly for excluding humans from that work environment. So they just detect if a human comes into the environment and then they stop the robot. What you'd really like to do is be able to determine what the human is trying to do and whether or not they're doing it safely in the context of that robot interaction. And those are the kinds of problems which are still sort of research opportunities.
Jagbir Dinta, Axon Drilling Products. More to related, this maybe is closer to the oil and gas. We've done a project where you do have the safety issue. They wanted the welder within the cell to view the welding process. We're a Motorman distributor, so they came up with a solution. They have a independent driver that lets that meets those standards, and so that's more of that's going on right now, and that's in Houston, and related oil field equipment using robotics for a manufacturing process.
Yeah, and it is happening right now in certain circumstances. There's a class of applications though where humans are literally interfacing with robots, like sharing tools or both working on the same work piece. And those are very difficult to get around today with the current safety regulations, and rightfully so.
Walter from Schlumberger. Are you aware of what work is going on in system verification for the software? I mean, not human robot interaction is one thing, but just verification for autonomous systems. and how do you approach that?
Yeah, so it's a very important topic, right? It's a little outside of my domain, and I may not have the full answer for you. But on the industrial systems, now they do allow for software in the loop on some of these safety systems. So that's how they are allowing this kind of human-robot interaction. And there are guidelines which are set up through these standards on how you test and validate those software solutions. I don't know all the details there. And one of the things that's really complex is it's more than just a product-driven problem, right? So you might have a sensor and a robot, and both of them are verified safe. But when you put them together, you have to verify that that system is safe, because they might be integrated in poor ways that are unsafe. And those are some of the issues that are trying to be addressed with these new standards, is how at a system level safety is maintained.
Michael Bihonic with Apache. One problem we have in the drilling industry is the environment is pretty tough on us. Being not only outdoors in that type of environment, but high vibration and things like that. Can you speak to the maturity of sensor development in that regard?
Yeah, sure. So, we deal with a lot of the same sorts of problems, right? And especially in mobile systems. So, like those unmanned ground vehicles and so forth. And it's a classic problem where whenever you have something that's mechanical, it tends to fail over time. So the DARPA Grand Challenge and Urban Challenge vehicles, they all use these scanning LiDARs. These basically you have a laser projector which rotates, and over time, inevitably, those things failed. Moving forward, there's things like more solid-state solutions, so like the Kinect, right, which tend to have higher reliability, at least from a mechanical standpoint. So the Kinect is nothing much more than an LCD panel for the projector and a camera, right, all solid-state solutions. One of the real challenges, though, is because now you have such a more complex data stream, being able to reliably manage or interpret that data is still an issue. So outside of the reliability of the sensor itself, can you adapt the data processing or the perception algorithms to deal with a complex or changing or dynamic environment? So the Kinect is not, it's an interesting product and it's a game changer in some markets, but it doesn't work reliably in sunlight. So you're not going to see that on an oil rig in the near term. But because everybody has seen the light in terms of how this can go for the robotics industry, there are organizations now that are working on more reliable solutions that deal with the kinds of challenges in reliability and uptime that are required in industrial settings. So that's why I kind of posed the question there in one of my slides, that whether or not these types of sensors and these types of solutions are really ready for industrial environments. And in some cases, yes, they may be, especially if you can constrain the environment to minimize the changing nature of them, or minimize the requirements on the reliability of the solution. And other solutions, they may just not be ready.
Charles Piper with IDE. Two-part question to follow up on that one. Are most of the sensors for the human interaction with the robot, are they mostly optic-based? And are they moving toward more sensors that are not such optic-based? In the oil field, dirt, pipe dope, just oil in general, tend to mess with the optics. And the second part is, how far along are y'all with the ROS, the Ross Industrial, with the PLC type communications to where it'll be easily integrated into the existing rig systems, more of the legacy systems?
Right. So yeah, the first question is optical sensing solutions. So yeah, typically just trying to think of any examples where they're not using an optical solution, and I'm not coming up with any. They're either typically some form of LiDAR, so a laser-based solution, or a camera-based solution, both optical systems. And so you're absolutely right. In your environments, many times optical solutions just aren't going to be viable. We deal with that in that paint stripping robot that I showed you in the very beginning. It uses a blast process, which creates a ton of dust, and you basically can't use an optical sensor. So, we're going to take baby steps in terms of implementing this, and go after probably the simpler applications first that allow us to use those kinds of sensing solutions. The second question with regards to the Ross Industrial program, it's really in its infancy. We've basically just started collaborating in the last probably 8 months or so with Will Garage, and we've done implementations now on a few robotic controllers, but have not gotten to, say, PLC-based control systems. We do have that in the vision, and that is part of what we hope to do with this consortium, which we're trying to put together, is to really build out that framework to cover the broader gamut of industrial control systems. We're not there yet.
Hi, Clay. Frank Chum from Chevron. Of the control system automation that you do, how much of them are involved with optimization, such as model-based optimization?
Yeah, I mean, optimization is a core capability in a lot of machine learning and perception algorithms, right? So, trying to think of an example where I had up there, but so for example, in an object perception pipeline, so where you're trying to recognize a known object in an environment, that's typically an optimization problem. You've got a very high dimensional space, which might be this 3D view of the world that you've created, and you're trying to do a fit of some model, which would be this object that you have interest in, to that 3D world. So that's a classic optimization problem that's used all the time in robotics. It's a really common framework.
Okay, thank you very much, Clay. Excellent presentation. Thank you.
Great stuff.
Work on the video in the